is Ryan Maluski. I'm the president of the Mizzou Space Program, and we're a competition team here at the University of Missouri-Columbia. Our main focus is the Spaceport America Cup in addition to the Argonia Cup. And we also do propulsion research, STEM outreach, EEE certifications, and a whole lot more.
We're the project co-leads for Argonia Cup 2024. I'm Cirrus, I'm a sophomore mechanical engineer.
I'm Cooper, I'm a junior mechanical engineer, and this is our fourth year competing in the Argonia Cup. Back in September, we started looking at many different types of designs for our rocket. We settled on packing our golf balls in a 3x3 stack, which fits inside of a 3.7 inner diameter tube pretty nicely. So from that, we decided that we were going to make our own custom composite tubes for the sustainer airframe. And we settled on around 150 golf balls at the sustainer because it's a high number, which should get us a high score, while still being a low enough number to be practical to fly in a rocket. In our booster design, we're trying to keep it as simple as possible. It couples with the sustainer motor with a commercial fiberglass tube and uses surface-mounted fins and a single-piece airframe. In designing our sustainer, we chose to use lightweight composites everywhere possible. We used 75mm motors because they fit in the 3.7-inch diameter of the sustainer nicely. And we sourced a very lightweight, low-volume rocket man parachute, which is enough to carry the weight of the sustainer but packs into a very small area. And we're using single separation dual deploy in order to save the length of a very long coupler avionics bay.
The Baker's dozen houses 154 golf balls, 4 in our nose cone, and the other 150 are 50 layers of 3 stacked on the upper side of the sustainer. We did numerous tests, both physical and simulated, to find an optimized packing pattern.
The booster for Baker's dozen is propelled by an Aerotech K1800 with a total impulse of 2,452 newton-seconds. The booster will bring Baker's dozen to an altitude of 1,931 feet at a velocity of 441 feet per second before separation. After separation, the booster will deploy a 3-foot rocket and float parachute attached to 15 feet of Kevlar harness, bringing it safely back to the ground. The total flight time of the booster section is 73.7 seconds.
The sustainer section of the Baker's dozen is powered by a Argonia L585 with a total impulse of 2,653 newton-seconds. The sustainer will ignite at booster separation and bring Baker's dozen to an expected average of 12,160 feet. Baker's dozen will reach a maximum velocity of 889 feet per second. At apogee, a 30-inch drogue chute will deploy, followed by the 60-inch main chute at 1,500 feet, before safely bringing the vehicle to the ground. The expected total flight time for the booster and sustainer sections is 226 seconds.
In our booster avionics bay, we have 2 separate flight computers. One is a Blue Raven and the other is a Raven 4. They're both wired up to their own charges. The first charge is for separation of the stages, and the second charge is for parachute deployment at apogee. Our sustainer's primary flight computer is a Blue Raven, which is wired up to the motor igniter as well as apogee and main deployment charges. The secondary flight computer is an Altus Metrum Easy Mini, which is wired up to secondary apogee and main deployment charges. We're using a single separation setup with a tender descender for main deployment.
To accomplish our ambitious airframe goals, MSP did a significant amount of wet layup composite research. 3 test tubes were wrapped to perfect our craft before wrapping both airframe and a coupler. This is in addition to an airframe and coupler sections. A custom nose cone was crafted in a 3D printed mandrel. The team's metal lathe was used to machine a tip for the nose cone.
For redundancy, both our booster and sustainer each have 2 separate flight computers that are wired 100% independently of each other for all of our ignition and deployment events. Also, following our failed launch at Argonia last year, and some dud ignition attempts at Spaceport America 2023, we switched our method of ignition for our sustainer following the advice of a local AAA prefect.